Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. 4-nitrotoluene, CH3 at C1, number 2 at C4. Moving on to the next step. The number 2 group is a meta-director and the CH3 group is an ortho-para-director. In 4-nitrotoluene, the two groups are in a 1,4 relationship. The CH3 is ortho-para-directing and number 2 is meta-directing. The combined directing effects place incoming Br ortho to CH3 and meta to number 2, which corresponds to position 2, ortho to CH3 at C1, meta to number 2 at C4. Thus product A is 2-bromo-4-nitrotoluene, CH3 at C1, Br at C2, number 2 at C4. Moving on to the next step. Reaction with SnHCl, reduction of nitro group to amine. The number 2 group is reduced to NH2, giving B is equal to 2-bromo-4-aminotoluene, i.e. 4-amino-2-bromotoluene, CH3 at C1, Br at C2, NH2 at C4. And for the final step, the NH2 group is converted to a diazonium salt N2 plus Cl, giving C is equal to 2-bromo-4-diazonium, toluene diazonium chloride, CH3 at C1, Br at C2, N2 plus Cl at C4. Reaction with H3PO2, hypophosphorus acid, reductive removal of diazonium group, Sandmeyer type replacement with H. The diazonium group at C4 is replaced by H, giving D is equal to 2-bromotoluene, CH3 at C1, Br at C2. Reaction with KMNO4-Ho, alkaline permanganate, oxidation of methyl group to carboxylic acid. The CH3 group at C1 is oxidized to Cu, giving E is equal to 2-bromobenzoic acid, Cu at C1, Br at C2, which is orthobromobenzolic acid. This matches option C. Benzene ring with CO2H at position 1 and Br at position 2, ortho. Why other options fail? A. Parabromobenzoic acid would require Br at C4, but Br was introduced at C2, ortho to CH3, and the diazonium at C4 was replaced by HB. Metabromobenzoic acid, Br is not at meta position relative to Cu. D. Terephthalic acid, no second methyl group was present. The Br at C2 is not oxidized by KMNO4 under these conditions. Therefore, the correct answer is C. Therefore, the correct answer is option C.